In this video, we talk about section 8.3, polar coordinates. We mainly talk about the relation between Cartesian and polar coordinates and how to convert between them and how to graph simple functions in polar coordinates. So given a point P in a plane, the point P is often identified by its Cartesian coordinates, that is, x-coordinate and y-coordinate. We know this is x from here to here. This is x, and from here to here, this is y. Alternatively, we also can identify the point P by specifying its distance from the origin and the angle. So the distance means the distance from the point P to the region. We call this distance r. The angle theta is measured counterclockwise from the positive x-axis to the line through the point P to the origin. The labels r theta are called the polar coordinates of point P. Sy is called the Cartesian coordinate. R theta is called the polar coordinates. Next, we look at the relation between Cartesian and polar coordinates. So from this right triangle, we see that x is equal to r cosine theta, y is equal to r sin theta. So r is equal to square root x squared plus y squared, and the tangent theta is equal to y over x when x is not 0. The angle theta is determined by the equation cosine theta is equal to x over square root x squared plus y squared, and sin theta is equal to y over square root x squared plus y squared. In general, theta is not equal to inverse tangent y over x. It's not possible to determine which quadrant theta is from the value of tangent theta alone. In general, theta is not equal to arctangent y over x or inverse tangent y over x. Now let's look at an example. Example 1, the first part is give Cartesian coordinates for the point with polar coordinates r theta given by p is 7 pi third. So we are given the polar coordinates of p, 7 pi theta. We want to find its Cartesian coordinates. So from its polar coordinates, we have r is 7, theta is pi third. So by the relation between Cartesian coordinates and the polar coordinates, we have x is r cosine theta, y is r sine theta. X is r cosine theta, so it's 7 cosine pi third. So it's 7 1/2, so it's 7/2. Y is r sine theta, is 7 sine pi third. So it's 7 square root 3 divided by 2. So 7 square root 3 divided by 2. So we get its Cartesian coordinate is 7/2, 7 square root 3 divided by 2. The next question. Give polar coordinates for the point with Cartesian coordinates x, y given by v is 0, -5. So we are given the Cartesian coordinates 0, -5. So in the xy plane, we can find the point of v. X coordinate is 0, y coordinate is -5. So this point is v. So we see the point of v falls on the negative y-axis. So we can choose r is equal to 5. R is 5. Theta is, so from here to here, this is 3 pi over 2. Theta is 3 pi over 2 for its polar coordinates. In this case, we can't use tangent theta as y over x to find theta. Because tangent theta is not defined. Because x is 0, x coordinate is 0. So because the angle theta can be allowed to wrap around the origin more than once, there are many possibilities for the polar coordinates of a point. So for this point of v, we can choose theta is 3 pi over 2. We also can choose theta is negative pi over 2, or theta is 7 pi over 2. However, we often choose theta between 0 and 2 pi. We often choose theta between 0 and 2 pi. So in this example, we choose 5, 3 pi over 2 as its polar coordinates. Polar coordinate. Yeah, this is example 1. Convert the coordinates between Cartesian coordinates and the polar coordinates. So the second example is to graph the simple functions in polar coordinates. So graph the equation y is 1 and the equation r is 1. The equation y is 1 is a horizontal line. On this line, each y coordinate is 1. We suppose this is the line y is equal to 1, horizontal line. R is equal to 1. Since we know r is square root x squared plus y squared, r is equal to 1, then take a square on both sides to get x squared plus y squared is equal to 1. So this is a circle centered at the origin, and the radius is 1. Radius is 1. Unit circle. So it's 1. So this is the unit circle. So here is 1. It's 1, negative 1, negative 1. This is the graph of the equation r is 1. It's the unit circle.